So for this question, alpha is a positive real number. The function f and g are there. The domain and range of the functions are given, and the functions are given as well, right? Both the functions g and f are given. We have to find the limits. Okay. So first I'll try to evaluate the value for gx for the given limit x tending to alpha plus. Okay. Let's try to evaluate this. Now you see, if I put x is equal to alpha, this will be going towards 0. This will be also going towards 0. So this is like log 0 upon 0 form. So that is kind of infinity upon infinity form, or you can say minus infinity upon minus infinity form. So we can use the L'Hopital's rule here, right? So I'll differentiate the numerator and the denominator, both of them once here, right? For the function gx, applying L'Hopital's rule. The differential of the numerator is going to be, this 2 is a constant, that is going to be there as it is, this times the differential of this, that is 1 upon 2 root x, right? Upon the differential of the denominator, we have to use chain rule, of course, 1 upon e to the power root x minus e to the power root alpha times e to the power root x times 1 upon 2 root x. Fine. Now these two get cancelled. So this becomes here now 2 e to the power root x minus e to the power root alpha upon root x minus root alpha. Now still you can see that this is again in the 0 by 0 form yet, right? So e to the power alpha minus e to the power alpha, that is 0, and then root alpha minus root alpha 0 by 0 form. I'll be applying L'Hopital's rule or L'Hospital's rule once again here. Differentiating numerator and the denominator once again. Numerator will give me, and by the way, I had this e to the power root x here also. But see, when two functions are multiplied, so this was like this into e to the power root x. So I can now put the limits for e to the power root x, x tending to alpha. This will become e to the power root alpha. Okay. And this is multiplied with the rest of things. And if I am getting a part of the product as something finite, I can put the limit, I can get the limits comfortably. So this 2 upon e to the power root alpha is there. Okay. I have put the value of x as alpha here because it is product. It is multiplied by this 0 by 0 form. So I can comfortably take that as, I can take the limit for that part. Okay. And this one, if I differentiate, I am going to get e to the power root x times 1 upon 2 root x upon root x. In the denominator, it is going to be this. Okay. So this thing here, this gets cancelled with this one. Okay. And I have the limit x tending to alpha plus. Okay. That is alpha from the right hand side. Okay. So when I put x is alpha, this is also e to the power root alpha, e to the power root alpha, they get cancelled. So I am left with just 2. That means x tending to alpha plus for the function g is giving me 2, right? Okay. Now what we can do, we now know that gx limit x tending to alpha plus is 2. But for this question, what we have to find out is this composite function. So we have to find sine of pi by 12 times gx goes as input for the sine function. So gx here, right? And the limit is for x tending to alpha plus. We know that this gx function is tending towards 2 for x going to alpha plus. So this is nothing but sine pi by 12 into 2, that is sine of pi by 6. That is sine 30 degrees 1 by 2. Okay. So 1 by 2 or 0.5 becomes the answer for this question. Right. Thank you.